Okay, let's talk about configuring single area OSPFv2 on a Cisco router. Now before we do, let's take a look at the network we have set up here. So I have 3 routers, and all routers are connected to each other over serial ports. Each router is connected to a switch and to a PC. And we've also got IP addresses documented. So right here you'll see the IP address for this entire network. And then above the devices, you'll see the IP address for the device. So this PC is going to be 192.168.0.10. Now the routers get a little tricky because we've got so many interfaces. So we put the IP addresses as close to the interfaces as possible. So here on R1, we have 192.168.0.1, 172.16.2.129, 172.16.2.137. So that should give you an idea of what the documentation looks like. And then if you've got Packet Tracer, you can replicate this easily enough. Now, the other thing to be aware of is at this point I have configured the routers with a host name and IP addresses, and other than passwords, that's about it. Alright, so let's talk about what we would have for a routing table so far. Now, routers automatically add in to their routing table anything that's directly connected. So R1 should have this network in its routing table, this network in its routing table, and this network in its routing table because it's directly connected to all 3 of them. However, it's not going to know about any of these 3 networks down here. Either this one off of R2, this one off of R3, or the one between R2 and R3. And there are 2 ways that we can make the router learn the route. So we can either configure a routing protocol and let the routers exchange information, or we can manually put it in. And that's static routing. And static routing works well in small networks, but as networks get larger, or if they change a lot, then that really becomes problematic. So we use routing protocols, and one of our most common ones is OSPF. And for IPv4, it's OSPFv2. So let's start by taking a look and seeing what we've got here. I'm going to open up R1, and we're going to give ourselves a little more real estate here. I'm going to log in, and I'm going to do a show IP route so we can see the 3 routes that we have. So we see 6 entries here, 8 entries if we count these little parent route entries, which are headers in the routing table. But the ones we want to focus on are the ones that start with a C, because that's a directly connected network. L is a local interface on a directly connected network. So you see right here I have 172.16.2.128/30. That's the network I can connect it to. My local interface on that is 172.16.2.129/32. And then /32 means it's a host route, or it identifies a specific IP address. So C's are my networks, L's are my local interfaces. So I have put in all 3 of, well, I haven't put in, the router has put in all 3 of the routes that it's directly connected to. Alright, let's talk about configuring OSPF. So I'm going to go to config T, and our command is IP OSPF, and then we're going to specify a process ID. And I'm going to get my question mark here. Router OSPF, not IP OSPF. Router OSPF, that'll work better. And you'll see it'll take a number from 1 through 65,000. Now, this number is locally significant only, which means every router in here can have a different process ID number. We have the process IDs if this router is going to be like a bridge router between 2 different networks. And so it's going to have OSPF running on 2 different networks, and it'll want separate processes. That's why we use that process ID. Now, it doesn't have to match the other routers on the network. However, it does make your life much, much easier if it does. So we're going to go ahead and say OSPF process ID 1. Now, the first thing we want to do is we want to set the router ID. And the command is router-ID, and then we're going to specify the ID, and it's going to be in the format of an IPv4 address, which, humorously enough, IPv6, which uses OSPFv3, also uses a router ID in the form of an IPv4 address. Now I'm going to set this to 1.1.1.1. That's going to uniquely identify this router on the network. Now, every router that's using OSPF has to have a router ID. You can either set it or it will pick its own. And the way it works is if you have a loopback address, it will use the highest configured loopback address. If you don't manually set it, that's option number 1. Option number 2, use the highest configured loopback IP address. Option number 3, use the highest active IPv4 address. But every one of them will come up with a router ID through one of those 3 methods. Now, best practice, configure the router ID. Then you'll just be able to memorize those router IDs, and it'll make your life much, much easier. Rather than trying to memorize the 4, 5, 6 IP addresses on any particular router, you're just memorizing the router IDs. And you don't have to work at committing it to memory. It'll happen over time anyway. Okay, so now we've got our router ID. The next thing we need to do is we need to start activating interfaces. Now, there's 3 different ways to activate interfaces. I'm going to move this off to my other screen here for a minute. So, you see we have 3 interfaces. Each one has an IP address. Now, when we activate the interface, it does 2 things. It advertises the network, and then it starts the OSPF process on it. So, if I look at this, I'm going to need my OSPF process running on these 2 links, or these 2 networks, because I want to share information with these 2 routers. I don't have any OSPF router out here for me to connect to, but I still need to activate it because that's how we're going to advertise this network. Now, the first way to do this is using the network command. So I'm going to type network, or net for short, and then I'm going to put in the IP address of the network. And we're going to start with this network right here. So my network IP address is 192.168.0.0, and then I'm going to put in the wildcard mask. Now, the wildcard mask is the exact opposite of the subnet mask. So this is a /24 network, which means the subnet mask is going to be 255.255.255.0. The easy way to calculate this is to just, on a sheet of paper, 255.255.255.255, and then subtract the subnet mask from it. So if my subnet mask is 255.255.255.0, it means my wildcard mask is going to be 0.0.0.255. Now, the other thing that we need to do is we need to define an area. Now, we're doing single area configurations here. And so we're just going to use area 0. You can use another area. Area 0 is better because it's going to make it easier if you ever go to expand your network into a multi-area OSPF network. Just make your life easier. So we're going to go with easy, and we're going to say this is going to be in area 0. Now, because all of our networks, or because we're doing a single area OSPF configuration, all of our networks on all 3 routers are going to be in area 0. Alright, so let's do this again. We're going to do this network, which is going to be 172.16.2.128/30. So it's going to be network 172.16.2.128/30 is going to be 255.255.255.252, which subtracted from 255.255.255.0 is going to be 0.0.0.3, and it's going to be in area 0. Okay. Some versions of the iOS will actually let you get away with doing the subnet mask instead of the wildcard mask. And when we say some, think current versions of it will. And this is actually easier. This is our 3rd network that we're going to need to put in, 172.16.2.136/30. That's going to be network 172.16.2.136, and this time we're going to put in the subnet mask, and /30 is 255.255.255.252. And again, we're going to go to area 0, and you'll see that it takes that command just fine. Now, it actually uses the wildcard mask. I'm going to exit out, and I'm going to issue the command show IP protocols. And you're going to see here we are routing for 3 networks, and here's that last one that I put in, and notice it is using that wildcard mask. It just automatically converted it for us. You see here our router ID is set. The rest of this we're going to worry about later. Okay, so that's way number 1 to configure OSPF. And we configure it using network commands, and each network command, we give it the IP address of the network that we want to advertise, and any interfaces on that network become active in the IP OSPF process. Alright, let's go to R2. And here we're going to do another configuration. Now, it's going to be similar. It's going to be just a little bit different. So I'm going to log in and show IP route, and you'll see again we have 3 networks connected. So remember, everything that's a C is a directly connected network, everything that's L is a directly connected interface. So I'm going to go to config T, router, OSPF, and remember I don't have to use the same process ID, but it just makes my life easier if I do, so that's what I'm going to do. Router OSPF1. You can just set a router ID, and I'm going to do 2.2.2.2. Remember, if I don't, it'll automatically choose its own. Router ID 2.2.2.2. Okay. Now, the first way we added network commands was to use the network command, or the first way we added networks was to use the network command and to identify the network ID that we're trying to advertise. And the other way to do it also uses a network command, but instead I'm going to use my local IP address on that network. So I'm going to do network 172.16.0.1, and then because I'm using a local address, I'm going to set the mask to 0.0.0.0. So remember, this is a /32, should be 255.255.255.255. The wildcard mask is 255, or the wildcard mask would be 0.0.0.0. So I'm just going to identify that interface. I'm going to say activate this interface, and in the process we'll activate that interface and the network that it's attached to. So do our next one, network 172.16.2.130. We're looking at this IP address right here. And 0.0.0.0, area 0. Network, our last one is going to be, remember we're looking at the L's, not the C's, 172.16.2.133, 0.0.0.0, area 0. Now before I hit enter, you'll notice that this popped up right in the middle of it. OSPF adjacency change, process ID, NBR means neighbor. Means I have now seen a neighbor with an ID of 1.1.1.1. We're connected on serial 0.0.0.0, or serial 000, the right thing here, and we just went from loading to full, and loading is done, which basically means we have exchanged information with them now. It threw that command up right in the middle of what I was typing. When that happens, don't worry, just keep going. There's a configuration that'll keep it from doing that, or make it so you don't notice it as much. But if you just keep going and hit enter, it's fine. It'll display the message, but it won't actually corrupt the command you were typing. So let's come out and see what we've got. We're going to do show IP protocol, and you're going to see now we have 2 routing information sources. We've identified 1.1.1.1, and we have our own router ID 2.2.2.2. We are now routing for these 3 networks. Notice that it's showing me the IP address, not the network ID, and then the IP address of my local interface, and then the area 0. Now, if I do show IP route, I should see that I have now added a couple of extra routes in here. And anything with an O means it's an OSPF learned route. So C means it's directly connected. I learned it because I'm connected to it. L is my local interface. O means I learned this from an OSPF neighbor. Okay. So, way number 1 to configure OSPF. Network command, identify network IDs, and wildcard mask or subnet masks. Way number 2, which we did here on R2. Use the network command and give it the local IP interfaces, and then it will figure it out from there. Let's go to option number 3. So we're going to open up R3, Cisco, and class to log me in, and show IP route. And we only have 3 things here because we haven't configured OSPF here. That makes sense. So I'm going to go to config T. I'm going to do router OSPF1. And then I'm going to set my router ID as 3.3.3.3. Okay, that's all the same. However, this time, what I'm going to do is I'm going to go to my interfaces and I'm going to activate OSPF on my interfaces rather than using the network commands from here in the OSPF router config. So I'm going to go to interface G00. And my command is going to be IP OSPF. I'm going to set the process ID 1, area 0. And that will add it to that network, or to that network to my IP OSPF process. So interface S000, IP OSPF1, area 0. Interface S001, IP OSPF1, area 0. And again, we had that message pop up and we don't care because that's fine. Okay, so now I've discovered two neighbors, 2.2.2.2, 1.1.1.1. Let's do, and we'll exit out of here real quick. Could have ended there to do it faster, but that's okay. Show IP protocols. And now we're going to see we have 3 routing sources, 1, 2, and 3. Notice that it doesn't show you what networks we're routing for. It actually is doing it, but we just don't see it. Let's do a show IP route. And now we're going to see that we are learning multiple routes. So there's a total of 3 of them we should be learning. One of them, this one right here, actually has 2 paths to get to it. And what it is this network right here. And so it's the equal cost to go this way or to go this way. We'll talk about cost in a later video. Okay, so everything is working now. We did the show IP protocols. I want to show you another command that's really useful. Show IP OSPF neighbor, or NEI for short. That shows me the neighbors that I have established an adjacency with. So I have a relationship with a neighbor named 1.1.1.1 off of serial 001. I have an adjacency with neighbor, or a relationship with neighbor 2.2.2.2. His IP address, and he's up interface serial 000. And I should be able to go to every one of these, show IP OSPF neighbor, and that looks better. And I should be able to see 2 neighbors on every single router. And that tells me that all of my neighbor adjacencies have formed correctly. And that's one of the ways you always want to check and make sure that your configuration is correct. Do a show IP OSPF neighbor and make sure you have the adjacencies you expect. Show IP route, make sure that you have all of the routes. Now you do have a few other show IP OSPF commands. So you can look at OSPF for a single process, or look at the database, or interface information, or so you've got a few other things you can look at. But the things that I find most useful when I am configuring OSPF, and then troubleshooting it if I screw up the configuration, is show IP OSPF neighbor, show IP protocols. Those are the things that I normally use. Now the other tools have some more useful information. We might take a look at some of that a little bit later in another video. But these are the ones that solve probably 95% of my OSPF configuration issues. Alright, there we go. We have configured single area OSPF on a simple network.